and minus material. They are all the applications we have already discussed, and we have already seen the differences between the sieves and the screens. Sieves containing the meshes in them, and there are two types of the sieves. One is plane wave, another one is a filled wave. And in the screen, you have got a drilling of holes in the metallic plate in the different sizes and the shapes. Depending upon that, you have got a slotted sleeves, fishbone sleeves, barred screens, fishbone design screens, slotted screens, a regular one which we are having a circular opening. What you are seeing on the screen now is the sieve which we are having in our laboratory, where the sieve number is number of meshes or the wires present in the 1 linear inch. 1 inch is equal to 2.54 centimeters or 25.4 millimeters. This is the top view of it. If you see, there is a distance between the two meshes or wires. This is called as a aperture size. Aperture size of the opening. Based on this, you have got a standards of the sieves. There are 5 different standards. One is number of sieve and aperture size of the sieve. In addition to that, you have got a nominal diameter of the wire, approximate sieving percentage area, 35 to 40%. GPAT question. It is the good one to maintain at 35 to 40, not less than that. It will reduce the output. More than 40, it makes the sieve very fragile. It means mutilated easily. Firmness will not be there. Aperture tolerance, the distance between the two meshes will be given one limit. We need to maintain it. If it is got distorted or deformed, we need to throw that sieve. We cannot use it because it causes the variations in the quality. This is what we have seen in the previous class. So we have discussed about this definition, application, difference between the sieve and screen, and standards of the sieve. And we have got different modes of the motion: agitation, brushing, and centrifugal force. This is actually the agitation method, to and fro motion. It is also called as oscillation. This is actually called as vibration. This is gyratory motion. This is circular motion. By these modes, the powder will be getting separated from the mixture of powders into separate fractions. And the fourth one is the brushing method. We don't generally prefer in our pharmaceutical industry. The brushing method contains the brushes in that bristles are present that will be getting removed and contaminating our product. That is not good. Or our product is inserted into the bristles and difficult to clean and make use the danger of cross contamination. That is the reason the brushing method we need to use very cautiously. This is the sieve analysis, sieve shaker machine. In this, we are arranging the sieves in a pile, one after the another, where the sieve number of least opening is present at the bottom. That is the highest sieve number, and sieve number of the least number, which will be placed at the top. That is, opening is bigger. Aperture size of the opening is bigger. It means the top sieve will have the biggest opening. Down, we are going to have smaller and smaller. At the last, we are going to have a pan. In this, we are going to open the lid, put the sample which we want to analyze at the top sieve, and we shake it for 2 to 5 minutes, depending upon the powder characteristic. Once you have shaken it, you are going to get a fraction of a powder separated in every sieve, because every sieve will have 2 fractions. One is plus material, another is minus material. Minus material will fall onto the bottom sieve. That again separates into 2 materials. Again, the minus material falling onto the further bottom sieve. Like that, the material will be getting separated into whatever the number of sieves we have used, that many fractions it will be getting separated. we need to remove the each fraction and weigh that. And we need to assign the diameter of the particular powder weight with the size. So that can be done by the data analysis step. This will be known in this, where we have got a arithmetic or geometric mean, where two sieves are present at the top and bottom. In between, one material is lying down. So the powder passing through the 36 sieves. Say for example, we have got the material passed through the 36 and retained on the 44 sieve. We know that 36 mesh has got 36 sieve has got 36 wires in one linear inch. 44 sieve has got 44 meshes or wires in one linear inch. And 36 mesh or a sieve has got opening of 425 micrometers, whereas 44 mesh which have got a opening of 325 micrometer. It means the material which is present in 44 means it has passed through 36 and retained in 44. It means it is having a size less than 425 and more than 325. The average is 375. Like that, we need to analyze the average diameter of given powder by taking the weight of the powder in between the two sieve numbers. We need to take the average of the aperture size of both the sieve numbers to assign the average particle size of a mass which is present in between that sieve. Again, we need to use data analysis by plotting weight versus size versus percentage weight retained, and we will be getting four different graphs. One is normal graph, cumulative percent undersize curve, oversize curve, probability curve. These are all the distribution curves which we are going to see. Depending upon the shape, we are going to determine what type of the distribution it is. This is the actually one part. And average particle size of a given sample can be taken by taking the all weights of material which is present in each sieve, and we need to take that as a n, that is grams. D we know that is a diameter. N into D we are going to get a ND, and we are going to use the formula sigma ND, add all and divided by sigma n. We are going to get a diameter, average diameter of a given sample. This is actually what the journey is. And in our laboratory, we have got sieve shaker machine appears like this. This one, because it is offline mode, we are going to use it, but it is in the online mode, we are not going to use it, but we are going to learn about it, because when we are opening the lid, we will be having at the top sieve, in that we are putting the sample, and we are going to get all the fractions present in the each sieve, and we are going to weigh it and assign the average diameter by taking top aperture size, bottom aperture size, both average. We assign the material diameter. Like that, we are going to analyze the pharmaceutical powder sizes. This is one another equipment is called as a Alpine air jet. This is what we have not touched in the previous class. Alpine air jet. Alpine air jet is the machine. Here it is used for the very fine powders, where you have got a problem of size clogging or blocking. Now, before going to this Alpine air jet, if anybody is having a doubt till now, they can unmute themselves and ask me whatever you have got doubts till now. We will be proceeding to the next topic of Alpine air jet. Otherwise, we will proceed. Later onwards, we will have a discussion. If anybody, you can place in the chat box also. If you are having in between any doubts, you place your doubt in the chat box. In the Alpine air jet, we have got a square type, that is cube-like structure. In that, it is divided into the two portions. One is the top, and that is the bottom. The top is the dome, which is containing sieve in between placed. So the sieve is going to separate the powder into two fractions that is placed above the sieve, and we need to apply air inlet from the bottom when air is coming, and it is forcibly making the powder to float. When the powder is getting floated in the top chamber, the minus material will come down and plus material will be staying above the sieve. And each time you are going to get two fractions of the powders. But in the sieve analysis, we have done one time 7 fractions at a time. We have got 7 fractions depending upon number of sieves. But here we have got only one sieve present between the two chambers. So you are going to get one plus material and minus material. Now, the minus material, whatever we are going to have, you collect it and change the screen to smaller opening. Again, you add it as a top of the machine. Again, you separate into the two fractions. Again, you will get a minus material at the bottom. Again, you take the minus material and change the sieve number and put the small sieve number, that is the small opening, and again put the material at the top. Again, you do it like that. Each and every time we want to separate into fractions, size separation, we need to stop the machine, change the sieve, and we need to place the bottom material again at the top. Again, we need to do it. Like that, we are going to repeatedly doing this particular process to get multiple fractions separated from the mixture of powder. Now you may get the question, sir, sieve shaker machine has got one step, we are separating all mixture into a 7 fractions. Here we are stopping the machine 7 times, we are repeating for the 7 sieves. It is a cumbersome process. Then why should we use it? We need to use sieve analysis only, sieve only for the determination of particle size. But here, if you see, you have got a inlet air supply and vacuum supply at the bottom. If you see, you have got a vacuum connection that will remove the fine powder and inlet air connection that makes the powder at the top floating. So these two arrangements will make the powder separated easily, because this Alpine air jet is used for the very fine powders where we are not able to separate in the sieve analysis. We need to use this only. Now you may get the question, why sieve analysis can separate this fine powder? Sieve analysis will be running by means of gravity. The material will fall. Here, if you allow it by gravity, that will cause the powder to get blocked in the mesh. When it's blocking it, you will get an output down. You don't get quality product out. For that purpose, you are creating a fluidization at the top, making the floating of the powder, separating them depending upon the size with each. Even any mesh has got blocked, because it is air jet at the bottom, you can push the blockage from the bottom and you can remove the blocks. It means blocks will not be any issue in this particular case. That is the reason this has got a specific advantage of using Alpine air jet. Of course, how much is the pressure difference we want to create depending upon our requirement, we can attach a manometer and see it. And there is a slit which has got a optional rotation to make your jet to move to the place where it has got the blocks also. So the top sieve cover here is completely airtight. In the case of sieve analysis, you don't have airtight. It is only just placed as a lid. So every time we are putting the powder at the top, getting 2 fractions and removing the bottom fraction again at the 2 at the top, and we are getting it in this Alpine air jet. These two are the equipment which are used for the testing. Testing means we want to take the sample and test how much is the size of that particular sample. So we are going to use in these two mills or machines. One is sieve analysis machine or sieve shaker machine and Alpine air jet, where we are going to have testing of a powder in the range of 1 gram to 100 grams. Now you may get the question, sir, I want to make my material pass through it. 1 ton of material in the production I have got. Can I do it? No, you can't use sieve shaker machine and your Alpine air jet for the production purpose. For that purpose, we are going to have another machine is called as size separation equipment. In the size separation equipment, we are going to use this equipment for the large amount of powders which are having the highest weight. Till now, whatever you have seen is a small scale lab equipment which is used for the testing. Now, whatever we are going to see is equipment is used for the production where we are not using grams, we are going to use kgs, and it is going up to ton. Mesh, it will explain that how many number of wires are presented in one linear edge. The Sieve number that will explain. No need to memorize or something like what you need to understand one time concept. Shaking screen. The screen is getting shaked. That's it. Simple one. You can articulate entire matter based on the same thing. Now, what is going to contain here? Of course, it is containing metallic frame that will be holding your material not to be falled or spillaged from out. And this is internally built with one sieve that has got a aperture size of the opening. Now you may get the question that it is given as a sieve, but you are giving in the bottom as a screen. We have made them different. Why it is being given? Sometimes it is being used as a misnomer also, but at the same time, in this particular equipment, your sieve is also equipped with a screen to give the enough strength, because we are using the tons of material. Sieve will be present at the bottom and the screen will be present at the top to give the support. If the entire material is falling onto the sieve, immediately because of that weight, the sieve will get distorted and your tolerance will be lost, limit will be lost. Then you cannot use that sieve. That is the reason it is supported with the screens also. That is the reason it is given as a shaking screen. It means actual material transfer equipment, material size separation equipment in this particular case is sieve only. The screen is only a support which is not present in this diagram, which is hidden. Now, it is not actually important for the size of the material what we are going to use. It is only for the support or prevent the distortion. Now, this entire metallic frame is connected to a shaft in the extreme left. The shaft is present in the eccentric rotating ring. The circular plate what you are seeing in the extreme left, it is containing eccentric shaft. Eccentric shaft means it is off-centered shaft. And this disc of a circular disc which is connected to a motor. When the motor is moving, this eccentric shaft is moving to and fro, makes the entire metallic frame moving to and fro. Oscillation is being done. During that movement, you are allowing the feed which is falling from the top by using a feed hopper. And the material is passed through the screen. You will get two types of material. One is plus material, another one is a minus material. One is oversized material, another one is undersized material. The undersized material will be discharged at the bottom and you are going to collect it. Now, you are having an entire equipment supported by hanging rods. These rods are present, it is a ODS rods. So hanging rods are meant to produce a support to the metallic frame freely moving by the eccentric shaft. At the same time, the hanger rods, they are having a different lengths so that that will produce a slanting effect. This slanting effect makes the material to slide down easily to entering into the discharge chute or a receiver container. Now, we are entering into the working part. When the motor is working, construction we have seen. What is the construction? First part is the metallic frame. The second part is the screen that is present bottom to it a sieve. Sieve is actually a size separation part. And we have got eccentric shaft that is attached to a motor. And we have got a feed hopper and a discharge chute. Discharge chute which will be containing in the bottom container. Now, entire setup is supported with a hanging rods. These are all the things which are present in the construction. What is that you need to remember? One is the metallic frame, eccentric shaft, sieve, feed and discharge, hanging rods. These are all the construction part. Now what material which will be used? Sometimes it is present in the material of made up of stainless steel, iron, or it may be sometimes copper. Depending upon our requirement, we need to make the entire one constructed by using it. Generally, our pharmaceutical industry uses SS, that is stainless steel, because it is a smooth surface and easily cleanable, rusting free, and we can wash it. And stainless steel screens are used. Now, these hanging rods which has got a different length, that is the reason it is producing a slanting effect. Now we are entering into the working part. How the mill is working now. When the shaft is rotated by the motor, the eccentric shaft takes the feed frame to and fro. Because it is moving in the to and fro, the feed which is received from the top will be separated into the two materials. One is plus material and minus material. The plus material is accumulated in the mill, or it is accumulated in the equipment, and the minus material will be sliding down and entering into the discharge. Now, if you don't have a material which is not removed in the top, my plus material, it will become a batch process. Batch process means you can load 100 kilo or 1 kilo or 100 kilo. After entire thing is getting separated, you need to stop the machine and remove the top material. Or you can make the small variation of this in the working to collect the top material separately, and you can get the continuous process. Continuous process means continuously you feed the material, get the plus material at the top and minus material at the bottom continuously without interrupting it. This is a small variation which will be present in the working. It means in the working, what are the points you have got? Movement of the shaft by the motor, addition of the feed at the top, separation of the powder into a two fractions, and collection of the material at the discharge continuously, and the optionally you can separate the material at the top continuous or batch. Now, sir, what is that one continuous and batch we want to use it? Say, for example, you have got a capacity of this mill, it can hold up to 100 kilo. Now, your plus material is only 10 kilo out of the ton, 990 kg is coming out as a discharge. Only 10 kilo is present. Then no need to bother about whether it is a continuous or not, because the capacity is, it can hold even 100 kilo also. 10 kilo only you are getting as a plus material. You can remove the entire ton material, you can pass it and you can remove it. No need to bother about whether it is continuous or not. Say, for example, your capacity is only 1 kilo and you can hold the plus material is only 1 kilo. In that case, what will happen? You have to stop every time once that 1 kilo is over, remove that 1 kilo, and again you need to feed the material and you need to make working. But in this particular case, you are stopping your machine. If you have got any option to collect that material as an formed without present as a piled up, or it is present in the equipment, you are making to slide down and collected as a plus material continuously, then you will have an option of continuous to collection of plus material and minus material. So this variation you need to employ if it is required. Coming to the another part, what is the critical parameters in this operation, unit operation? Now you don't get confused. Operation now onwards, whenever you are using, it is not a medical operation on the human body. It is a unit operation which is present one step in our process. So in this unit operation, we are using size separation as one step in the unit process of tablet manufacture or capsule manufacture. Now, this material which is passed, output will be present on based on the what are the critical parameters when the output or the quality or the time of manufacture will be based. We have already discussed in the first class itself. We need to be fast enough, cheaper enough, at the same time quality enough. So we need to have a quality also. At the same time, cost should be less, and we need to be very fast. So in order to do that, what are the critical parameters in this? The critical parameter in this case is movement of the shaft, rotating. If it is oscillating very fast, separation is very fast. Output is very fast. Now, the second parameter in this particular case is if you are making a slant, it is parallel in nature, there is no slant, then your material discharge will not be getting faster. So you need to create a slant. So angle of slant is one parameter is present here. Sorry, angle of slant, why can't we make it too slanty in such a way that you will get too much of output? But the problem is, if you make the too much of slant angle, the material will be coming down without separation also. Your minus material is present in the plus material, but it is collected as a plus material only, even though it is containing. It means too much of slant is also not good. The critical parameters in this particular case, angle of slant and rotation of the shaft by the motor. This is actually one thing. Another one is a feed rate. If you are allowing all 100 kilo fall into that, and it will take a lot of time. If you are allowing slowly, 10 kilo one time, 1 minute, 10 kilo per minute like that, then it is excellently, it will be smoothly booming it. This is the one which you need to understand. Now, advantages and disadvantages. You need to answer in the question. The advantage of in this particular mill is it is advantageous to use the larger material. But the disadvantage in this particular mill is blocking. Blocking means you are going to have clogging of these sieves, and which you need to remove it separately by stopping the machine, take the brush, and you have to rub it so that you will be removing the clogs. It is a time consuming process. This is actually one disadvantage. Sometimes we will be asked the question like application. The application is it is used a commercial equipment used for the tons of material to get separated into the two fractions. One is plus material, another one is minus material. And you will ask sometimes along with application limitation. What is the limitation? Here you are going to get a mixture into only two fractions. That is the limitation. You cannot separate into 10 fractions or 7 fractions or 5 fractions. Only two, plus material or minus material. This is actually a limitation of it. Now, how to solve this limitation? You have got plus material and minus material. You take the minus material, again replace the sieve with another sieve, and again you place it, and you get a minus material. Again you put it like Alpine airjet, what you are doing it. But it is a time consuming process, and screen is also very heavy in nature in the industrial setup. It is not worth to do. We need to find the alternative to have a separate equipment to have all these limitations and disadvantages solved. We need to have a invention of another equipment so that we will be having a better facility, and you can get the better quality product in the faster manner and also in the cheaper manner. I hope till now, if you are able to understand, it is okay. If you have got any doubts, ask me. We are going to the next step. Now, the next advancement, the next generation of this particular shaking screen is called as a Rotex screen. So what we have got 1G, 2G, 3G, 4G, now it is going to 5G, 5th generation. Like that, our shaking screen is a age-old phenomena. It has got its own disadvantages. We have already seen we are getting only two fractions, multiple fractions are not there, blocking of the screens are present. These are all the problems. Next generation screens, that is called as a Rotex screen. Very important for your sessional and your main exam. Now, we will see the construction part of it. It is containing at the top, if you see the first construction part is, it is containing the screens of different sizes. Screens of the different size. What is the different sizes? It is containing a opening of a different openings which are present. So the top sieve, which is screen, is having a bigger opening, then the middle, then the bottom. So the top screen is bigger, middle is smaller, smaller, bottom is further smaller, like that. So it is containing screen. If you see here, you have got two screens. One is a support screen at the bottom, and original screen at the top. What is the purpose of supporting screen? The supporting screen is to hold wooden block and rubber balls. What is this wooden block and what is the rubber ball purpose? This is what we are having a next generation. It is a little bit idea which is there, and this idea has prevented the clogging and blocking of the screen. We are seeing here this entire screen system is containing the top original screen, the bottom which is having a supporting screen which is coarser than above screen. It means it is having a wider opening than the above. Its purpose is only to hold wooden blocks and the rubber balls. So what is the function of this particular wooden balls and rubber balls? Now you see we are placing the top screen and the bottom screen in between wooden block and the rubber ball. The same way the eccentric bearing is present in this case also. When the motor is moving, this entire screen, Rotex screen, is moving to and fro. When it is moving to and fro, what will happen? We are going to have the material which is fed at the top, which is going to fall onto the top screen, and minus material will come down, and plus material will be slided down, which is separately collected in the discharge. There are 4 arrows present in the bottom. In the extreme right, you are going to get a coarser size, and that is the plus material of the first screen, and the minus material of the first screen, that is the entire set which is present. Then it is going to the middle setup. In the middle, it is separating again plus material and minus material. The minus material will be falling onto the third screen in the bottom, and the plus material of the middle, it will be entering, and separately it is going in the second arrow in the present in the extreme right. Now the material which is present as a minus, it is falling onto the third screen. In the third screen, it is again separated into the plus material and minus material, and again the minus material is coming as a fine powder, that is fine size, and we are going to get the plus material as a separate fraction. It means the feed is one mixture containing 4 different fractions separated at the bottom. In the 4 bins we are going to place and separate them. I hope you understand now. In the previously rotating screen, what is the problem? You are getting only 2 fractions, plus material, minus material. Now we are getting one feed mixture, 4 fractions we are getting, 4 arrows we are getting, different sizes of the 4 materials we are getting it. Whatever the material which we use in our pharmacy, we will be using, sending that to the production. For immediate release, fine fraction will go. For sustained or prolonged release, we are going to use a major, bigger fraction. So accordingly, we will be using it. Now, what is the purpose of this wooden block and the rubber ball? That is the main question you need to answer in the exam. The purpose of the wooden block and the rubber ball is, when you are rotating the screen, the rubber ball will hit to the slant surface of your wooden block. The wooden block is not present as like a cuboid or cube. It is present as a trapezium-like structure. If you see, it has got a slant surfaces. Because of that slant in nature, the ball will hit to the slant, and it's the similar force, it will go back. It is a rubber in nature. So when you are hitting a ball to the wall, it will come back with the similar force towards you. In the similar manner, when the ball is getting hit to the slant surface, it will hit in the similar force to the screen also. When it is hitting to the screen, it will remove the block, because we are removing the hitting from the bottom. So the blocks which are present in the screen will be removed by this mechanism. Again, it will hit to the screen. Again, the ball will hit to the another block, and it is going to hit to the bottom screen. Again, it will hit to the wooden block. Like that, the balls will be keep on hitting to the screens and removing the blocks. This is actually what is another feature which has been placed in this. By keeping the wooden blocks and the rubber balls, we are going to have a prevention of the blocks. In the previous screen, if you see in this particular machine, it is becoming a batch process, because after a particular period of the time, the screen is getting blocked with the powder. You need to stop, and you need to remove the blocks, and you need to use it again. it is not a continuous process because it is causing a blockages. There is no option here to remove the blockage of your pores in the screen. But in this mill, it is not like that. As and when the blocks are created, it will be removed by the ball. The ball will hit back and remove the block. And it will be separating it to a plus material and simultaneously minus material. And another advantage in this particular case is, here you have got one screen which is present. Now you are going to insert 1, 2, 3 screens. Here you have got only one screen, you are getting a 2 fractions. Here you have got 3 screens, you are getting 4 fractions. That is actually what the advantage of this particular Rotex screen. And it is very important for your exam and GPAT. So the GPAT, you will be asked additional feature in the Rotex screen. Additional feature in the Rotex screen is you will be having options like anything, whether it is a supporting screen, wooden ball, rubber ball, wooden block, and all of above. All of above will be present. Sometimes it will not be that much easily you will be asked. Sometimes you will be asked what type of the screening equipment. We have got the option of wooden block and the rubber ball. Then you need to rightly read the Rotex screen. Now, in the sessional examination, you will be asked construction and working of Rotex screen. You know, now itself you can tell me easily. The construction part is, it is containing the multiple sieves. Each sieve is equipped with one support bottom screen. In between, you will be having a wooden block and rubber ball. And you have got a feed at the top and the discharge chutes, which are present 4 separate discharges to collect coarse to fine powder. And this is connected to a eccentric bearing. It will be moving to and fro, makes the screen to move to and fro. So it is a construction. Construction means you have got a casing, and in that you have got a screen, bottom screen for support, wooden block and rubber ball, and eccentric bearing. And you have got a feed and the bottom 4 bins to collect 4 fractions. This is actually construction part, working part. Now we are going to entering into the working part. Very simple. By seeing this particular mill itself, you can very well say, when the material is fed at the top, it is passed through the first screen and it is separated into 2 fractions. The first fraction is collected as a plus material, as a coarse size, separately in a bin, and the minus material is falling onto the middle screen. It will be again separated into the plus material and minus material, and the minus material is again falling onto the third screen. Again it is separated into the plus material and minus material. It means each time we are going to get 2 fractions when it is passing to the each screen. We are going to get 4 different fractions by feeding a mixture at the top. At one time we are going to get 4 fractions. This is actually what the working part of it. And critically you need to write the function of wooden ball and the rubber ball and wooden block. The presence of the wooden ball and the rubber ball in the working of your machine, it is creating a impact of your ball, that is rubber ball, onto the screen, removes the blocks. Here the blocks are removed as and when they are formed by hitting back by the rubber ball. And you may get the question now in your mind, sir, instead of wooden, why can't we use metal blocks? Metal blocks are heavy in nature. That is the reason it will cause the distortion of the screen. It will make the bend in the screen. That is the reason lightweight material is better. Now you may get the question, wooden block may cause the problem of contamination. If that is the case, it is better to coat with a material like a Teflon, like that. You can have the contamination problem prevented. Now, you are going to have a application and a limitation. What is the application and the limitations? Application is, it is a continuous mixture, continuous size separation equipment. Continuous means you are going to get the feeding of material continuously and getting the output for material output continuously. This is actually what the mean by the continuous equipment. Now, what is the limitation of this? The major limitation can you understand here? If the material is falling between the wooden block and the rubber ball, sorry, the material is getting broken into powder. When it is material is falling by the impact, if it is falling between the wooden block slant surface and the rubber ball, it will be fractured. It will the material will be getting reduced in the size. This is major limitation. It means we want to separate the size, not to reduce the size of the powder, but there are some chances of probability of falling powder between your rubber ball and your wooden block. During that hitting of a rubber ball, the material may get broken into the smaller pieces. You will get output smaller than what you have actually fed. This is actually what the major limitation. Now, you will ask sometimes applications, limitations. In addition to that, you will get advantages and disadvantages. Advantages. The first advantage in this particular case is a commercial equipment. It is production used and it can used for the tons of material. And another advantage, there is no blocks here, so it is having a continuous operation. Now, because it is a continuous operation, you can feed the material any number of tons and you can get the material output. Only just you need to remove the container when it is filled and you need to place it. That's it. So continuously you can feed the material, continuously you will get the material. This is actually a continuous operation. You can get even 1 kilo also, 1 ton also, 10 ton also. No problem, because there is no blocks. This is actually another advantage. The disadvantage in this particular case is, we have already mentioned, the powder may be broken into the final powder. So the final powder, which is not actually desired for us, we want to separate it, not to reduce the powder, but there is some size reduction is actually taking place as a disadvantage in this particular case. I hope you have got all the points: construction, working, applications, limitations, advantages or disadvantages. Once you know it, remaining everything will be known. Now, we are going to know what are the variations in this. A variation can be made by inserting fourth screen in the bottom of third. Further fine, you will get 6 fractions, 5 fractions. You insert five sets of screens, you will get 6 fractions. Depending upon number of fractions you want, we can vary this particular Rotex screen by inserting that many number of screens. It means if you want to get a 6 fractions, you need to insert 5 screens, different 5 screens. You will get a n+1 fraction. It means you have got a 5 Sieves screens, means you will get a 6 fractions. If you want 7 fractions, you need to insert 6 Sieves, 6 screen sets. What is screen set? The top screen, the bottom support, in between you have got a wooden block and rubber ball. That's it. This is actually what the variation. Now, we have got another parameter called as a critical parameters. What is criticality in it? In this criticality, if you see logically, the to and fro motion, how much faster it is making it, too slow or faster. That is one. Of course, it has got its impact. And slope angle, that is the slanting angle. It should not be too high and it should not be too low. That is second parameter. And the third one is number of wooden blocks and balls. If you are placing only 3 wooden blocks and 3 balls, you can place 6 balls and 6 wooden block also in your equipment. You can place 8 wooden balls and 8 wooden blocks also, rubber balls also. It means when you are placing your number, your clogging will be avoided, but at the same time you are placing too many. It means you are just filling entire screening surface. Then your screening area will be very less. It should not be done. At the same time you are not putting optimally. Then it is also a problem. It means there is another critical parameter, number of wooden blocks and rubber balls also critical here. We need to understand that. I hope You have got the point now to be noted, and see that you are able to understand this. If you have any doubts are there, let me know, because it is very important question in the exam. Don't ask me later, sir, give me the important questions for my first sessional examination. In the regular running itself, I will say you, this is very important. It means that no need to ask me later, you note down in a book. That is the reason, whenever you are attending the class, do remember to place one notebook along with you with pen and write wherever it is coming, where it is repeatedly told, very important. Where it is being told only once, you can make the number of stars issued to that. When I'm telling very so many times, it means that you can add a number of stars in it. Wherever you are going to get that name of equipment more and more stars, then you are going to get a probability of that question very high. I'm not going to say you anything in later, this is important question, it is follow, because I don't suggest to follow or read only one and leaving everything as a choice, because in our pharma industry we should be 100% learning, and it is very easy also as a flow we need to study. Now, whenever you are attending the class, you are taking one notebook. Don't take as a stray papers or a pamphlets or anything which you want to note down. That book should be as a not distortable or removable. Such things is better. Otherwise, these papers and everything, it will go away. At least it will be present with you. And I have asked you to already prepare for the GPAT parallelly. Whenever you are reading after this class is there, go to pharmaceutical engineering book and try to study this. What is this Rotex screen? What is the shaking screen? And it will be given as a matter here, and you study. After studying it, you take a stray paper or a waste paper, anything or any waste pamphlet. Book closed, draw the diagram with your own hand. No need to be artistically presented. Just to do remember that you need to put all construction parts are coming or not, whether the diagram is good to see. It should not be present like anaconda. It is present like a snake. Somebody draw this particular one in the like a snake. It is very scary for the examiner to correct it. Don't do that thing. No need to be artist like MF Hussein, like exactly Sar has given the screen and I will present in the similar manner. No need to do that also. What you require to do is, you need to provisionally present all construction part present. It should not look like a strange feature. That's what you need to remember in the exam, because in pharmaceutical engineering, you are going to draw a picture, it is provisionally looking. Now,